with HealthMap, which we just started, has been very interesting and unique. And once again, what it shows, why are we going to build this if we can essentially work out a relationship with somebody else so that data can flow bidirectionally, programmatically? The biggest area that we are focusing on going forward now is this issue about metadata. And this is a very complicated issue in biology. The real difficulty, of course, is that as we have thousands of genomes and transcriptomes and stuff like that, why should you be interested in genome number 555 of E. coli? Well, you don't know. But if there's data about this genome, metadata about where it was collected or what the phenotype was on a human being, or if it's part of an outbreak study or blah, 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 you might be interested. And so right now, the problem is that there is essentially no metadata standard out there for the kinds of data we want to acquire. There are a number of groups working on this, and we're connected to all these groups. But once again, the problem is that the need and the technology is moving ahead of the standards all the time. So our goal is to comply to existing standards, but also develop whatever we need to develop and suggest that the standard bodies, implement further extensions in support of infectious disease. This particular visualization is a generally useful visualization. It's just a 2D visualization. Biologists look at this and they immediately want to call it a heat map because they used to that term from analyzing transcriptomes. But you can imagine that on these axes you could put anything. In this case, on these axes we have genomes and protein families. And so obviously you can start to look and why is this whole set of genomes here doesn't have some protein family, and you might become interested if you